Good morning, everyone. My name is Eric Walsh. I am a student of mechanical engineering, currently attending Central Georgia Tech. Today I'd like to share some time and go over a basic concept of engineering is friction, force, and pressure. I've taken the liberty due to time constraints to go ahead and construct an analogy of a wooden box weighing 40 kilograms that will be sliding across a level wooden floor. Before I get into this problem, I'd like to define force, friction, and pressure for you. Force is the push and pull on any object. Friction is the resistant force of bodies at the point of contact, and pressure is the resultant force of force being applied to a cross-sectional area of a material. I wrote our constants up here. F1 is going to be our positive axis pulling force. M1 is our mass of the box, which is 40 kilograms. Mu is going to be our friction coefficient, which you can find in an engineer's handbook, or you can even look it up online. Scientists do all of that back work for us, so we won't have to, and we just plug in this number. This G is the force of gravity, which pushes down consistently on planet Earth with a force of, or a negative acceleration of, negative 9.81 meters a second squared. To work through this problem, I went ahead and wrote out our symbolic manipulation, which will be plugging in numbers to derive our acceleration force through Newton's law of force equals mass times acceleration. The first thing we need to do to find the force of gravity acting on our weight is multiply our weight times that negative acceleration of negative 9.81 meters a second squared, which should come to 392.40 newtons. We will take this figure and multiply it times mu, which is our friction coefficient. And we find that 0.35 times our 392.40 newtons lets us arrive at 137.34 newtons, and that should be a negative because our gravitational force is a negative acceleration. So this force we'll call our friction force between these two bodies of the wood table and the wooden box. Since it's a negative force, we can deduct it from our positive F1, and we'll find that 200 newtons minus our 137.34 newtons equals 62.66 newtons. If we take this figure and divide it by our mass 1 of 40 kilograms, we will find that our acceleration, a constant acceleration of 1.57 meters a second squared rounded is our answer. In conclusion, I'd like to say that the force of gravity times the weight of the box multiplied times our friction coefficient gives us the negative number we need to deduct from our positive pulling force, divided again by the weight of the box, gives us the acceleration. And this is all derived from Sir Isaac Newton's Second motion of law, force equals mass times acceleration. Thank you very much, and I hope this problem and working through it has helped you. Have a great day.